Solving systems of equations is a major mathematical concept. It's nothing new. We've actually seen solving systems of equations in Foundations and Pre-Calc 10. Those were limited to systems of equations involving two lines or two linear equations. What we would do then is we would graph out the equations, we would see where the lines cross, and that would be the solution. Alternatively, we could go at it algebraically, use mathematical methods, and determine the point of intersection that way. So a system of equations is two or more equations. We're going to limit ourselves to those with two equations just for simplicity's sake. What solving a system means finding all the values of each variable, we'll deal with x and y, that satisfy the equations. And what does it mean to satisfy an equation? It makes each equation true when we substitute that value in. Today, we'll be dealing with solving systems graphically, meaning we will actually look at the graphs of the equations. We're going to look at two different types of equations. We have linear equations, they make lines. We're also going to deal with quadratic equations, parabolas. We've dealt with those extensively already. We're going to keep dealing with them. So when these sets of equations are graphed, they could cross in any number of different ways. The first three will deal with a linear and a quadratic equation. We could actually have no solution, no point of intersection. Those graphs may not cross, and that's entirely possible. We may have a situation in the middle where they just touch at one point and we have one solution. We also may have a situation where they cross twice and have two solutions. No matter what orientation we put these in, no matter how we arrange them, 2 is the maximum number of solutions for a linear and a quadratic system. Likewise, we could have the same 3 situations for a quadratic system, 2 parabolas. They may never cross, they may touch once, or they may cross twice. We'll never have more than 2 as well, no matter how we draw them. So let's take a look at a situation. We've got a springboard diver going from a 3-meter platform. Coach uses video analysis, and this is a simplified graph of what the video would show, but the video would show 2 different things going on. One, we would have the diver going off the board into the water, and we'd also have the height of the water. So we need to take a look at each system and see which ones could possibly model this situation. Since we're dealing with a springboard dive, that means it's somebody who's actually jumping up off the diving board, hitting a peak and going down. So from that point we can eliminate system B. Why? I'm going to assume that the diver is in dark blue here. And if the diver is actually jumping up, that blue line would need to move up. That blue line is simply moving straight down, so that does not fit our situation. Likewise, I'm also going to eliminate system A, even though if the diver is in dark blue, the diver is going up, hitting a peak and coming down. If the light blue or the green, depending on how that shows up, line acts as the water, that would tell us that the height of the water is actually going down. Well, anybody who's dived off a diving board knows if the water is draining out of the pool when you dive, that's dangerous at best. So we're going to assume that the height of the water remains the same. Leaves us with C and D, and there's a very slight difference between the two of them, and it has to do with the starting point right here. In system C, that starting point is above the height of the water. In system D, that starting point is at the same height as the water. So then we need to use a little bit of common sense, and we need to figure out, well, on a diving board, do you start above the water or do you start at the water? And in fact, you do start above the water, so system C would be the correct solution. Question B is to interpret the points of intersection in the system you chose. Well, points of intersection, there's only one in this one. It's that one which I've just outlined in yellow. What does that mean in this case? It means this is when the diver hits the water. And visually, this graph matches exactly the situation. To the left, before the diver hits the water, she's above it. To the right, after the diver hits the water, she's below it.